We'll now be doing the initial setup on the rig. So I'll be entering my rig node. I'm then going to select my BugRig HDA and I'm going to open its type properties. We're going to be working in the Extra Files tab. I've already got some geometry imported. This is just a small set of pre-made controls. I'm now going to import the geometry for my rig. I'll start with the mesh geometry. I'll add it using the Add File button. After the mesh, we'll import the skeleton. You should make sure that you do not accidentally add it as an empty section. We can then apply this and accept to save the changes. We can make sure it's saved properly by right-clicking on the node and clicking Save Node Type. We can now enter our rig and I'll get a file node. I can use this file node to import my base mesh geometry. This will give us our mesh, but we don't want to reference this geometry externally. Instead, we want to get the geometry which we have embedded in our HDA file. There are various reasons for this, the most obvious one being portability. The HDA can be transferred without having to worry about any of the external geometry. This also means that if any of the external files go missing, it will not affect the HDA. We will do this using the command opdef. This is referring to the HDA's definition file. Opdef will be followed by a colon, and then we'll use a directory structure to reference the file. In this case, the HDA is the direct parent of the file node, so it will be ... We'll terminate this with a question mark, and then we'll have the file's name. I'll name this file node mesh. We'll get a second file node, and we'll use this file node to get our skeleton. Once again, we'll be getting this from the HDA. opdef : ... question mark, and then we have the file's name. We'll get my final file node, and this will be for my controls. opdef : ... question mark controls.bgo.sc. I'll then rename the nodes. There'll be the skeleton node and there'll be the controls node. I'll then just give all of these nodes a suffix to make sure there's no naming conflicts. In this case, the suffix will be in. We now have our respective geometry and can begin the initial setup. So we'll start with the skeleton and I'll get a delete joints node. I'll plug the skeleton into the delete joints node and then I'll duplicate it by alt dragging. I'll then get a null. I'll place this between the file node and the duplicate joints node, and then I'll make a duplicate of the null. This null is essentially going to serve as a placeholder. I'll call the first of these nulls retarget. This is where I'll insert the retargeting network for this rig. The second null will be named FBIK. Like with the first null, if I decide to add in a full body IK, it will happen here. As stated earlier, these nulls are placeholders. I haven't decided whether I'm going to use them yet. We'll start with the first delete joints node. This branch will be used for the FK, and I'm going to delete 2 points here, which are the head up and the abdomen up. Any joints which are only here for controls will be removed at this point. The second delete joints node is going to be used for our IK controls. What we'll be deleting here are the second joints from the legs. For the legs, we will want an up vector, a root, and a tip. So we only need 3 points, so the extra points can be deleted. So this will give us our initial control positions, but we'll want to add the actual controls to them. We can now work on our controls file node. This is going to be a reasonably simple structure. It's going to start with the blast node. We can then select the group. I'm going to start with the box. We'll activate delete non-selected. We'll then get a name node. This will be named box. We need to give the controller name so it can be attached to the rig. We'll then get a transform node. This is so we can scale our control. I'll scale the box down to about 0.04. Then we'll give it a color. I'll make this control blue. One of the reasons I'm using geometry for the controls rather than a control node is that it is easier to color geometry for the controls. Controls made with the control node are actually far more difficult to color. I'll then connect this to a merge node, and I'll get a null to use as an out node. This null will terminate the network, and we'll refer to this now when we want to access the controls from other parts of the network. We'll then go to the rig network, and I'll get an attached control geometry node. This will be connected to my second delete joints node. I'll then add my first set of controls. We can select the first group. This will consist of all the leg effectors. We'll need to get our controls geometry, so I'll get an object merge node. We'll set the transform to be into this object. I'll then reference my controls. I now should be able to set the control name in my attached control geometry node, and I'll set it to box. Here we're setting the IK controls. I want all of these controls to start with a neutral rotation. So basically I want to zero out all of the rotations for these controls. I'll be setting these transforms using the rig attribute VOP. This will apply to all the transforms, so we'll get a getPointTransforms node. I'll set the GROUT value to be everything. This will be done using an asterisk. We'll want to loop over all of these points, so we'll get a for each loop. We're going to be looping over the points. And then we'll get our information using a getArrayElement node. So we'll start by getting an element from our point array, and we're going to get each individual point using an index. This will allow us to work on each point individually, and we'll set each point using the setPointTransform node. This will be set using the point number, and we'll get the point number from our getArrayElement node. We'll want to set this point's transformation matrix. We need a matrix, and we'll need to convert this matrix. So first I'll get a matrix to vector4 node, and we'll want to get the information for this using the transforms of the individual points. However, we cannot use the transforms from the getPointTransforms node. That is because this node produces an array of transforms. We'll need to get and set each transform separately. So I'll duplicate the getElement node, and we'll set this node to use the transforms array. This way we'll loop over every point and its transform. We can then take the output of this node and plug it into our matrix to vector4 node. I will then want a vector4 to matrix node. We'll keep the positions and leave everything else to be default. If we do not change any of the other vectors, we'll receive a standard identity matrix for the rotations. And this will leave us with neutral rotations on all of our controls. In the viewport, we can see that our controls have better alignment as well. There is a reason I say the control alignment is better. This is because we do not want to see a rotation on the control that does not represent a rotation on the rig. Your IK controls all control positions, and therefore should not actually be rotated. This is contrasted with your FK controls. The FK controls all control rotation directly, so rotation there is crucial. Here we can take a look at the controls transforms, and we'll see that the transforms are all zeroed out. We'll continue adding the controls. Duplicate the section where we created the box. I'll duplicate this a few times. I'll select the blast node. I'll set the group for a control which I call directions, and I'll remove the reference to box. I'll then set the name to be directions. The uniform scale parameter in the transform should then be set to 1, and I'll set the color to be green. This can be connected to the merge node. We can then add the next control to the controls node. This control is pretty straightforward. It will connect to the root joint, and I'll set my control name to be directions. I'll then rename the blast nodes. I'll name the first one box, and I'll name the second one directions. The next one will be my center of gravity, which I'll abbreviate as COG. I will change the value of this to my plane YZ, and I'll set the name to be COG. I'll set the uniform scale to 1 again, and I'll set the color to an ochre. I've selected the wrong plane. This should be the XZ and not the YZ. And I'll change the color to yellow rather than the ochre. As the name suggests, this will connect to my center of gravity joint, and the control name will be COG. 'I'll then tweak the scale a little bit. 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 'I'll then The next control will be called my leg up. In this case, I'm going to use my prism control. I will leave the scale as it is, but I'll set the color to be a dark purple. This will then be attached to my leg joints. I have not changed the name. The name should be leg up. I'll call the next controls look up. This is because they're going to be used in look-at solvers. The name will be lookup, and the color will be a blue. I'll set its shape to be an octahedron. We'll link it to the merge node, and then I'll attach it to the rig. We'll add the next set of controls, and these will be the head up and the abdomen up controls. I'll then set lookup as my control name. I need to correct the blast node as box is still in the group. The next control will be called look at. This will be a circle XY. I'll set the color to be red. The name will be look at, and we'll add it to the object merge. We can now add the final controls. This will be for the head effector and the abdomen effector. And the control name will be our look at. I can then enlarge these controls slightly using the uniform scale. And those should be the controls which I'll need for the IK. I'll then group all of these nodes together, and I'll label these IK controls. I will call this last control FK rotation. I'll set the group to be a sphere. Once again, I'll make this a purple control. I'll connect this to the merge as well, although we will not be using it at the moment. We now have the basic setup. We've set up the controls. I've split up the basic rig, and I've brought in the mesh geometry. And now we should be able to start rigging, and we'll be doing that in the next video.